In this video, we're still doing a little bit of review. You should have talked about bisectors before, so we're just talking about the bisector basics in this video. So again, this might be one you're able to skip. If not, go back over the basics, make sure you know. So a segment, ray, or line, or plane that's perpendicular to a segment at its midpoint is called a perpendicular bisector, and that's what we see in the picture. Here I have a segment, and I have a perpendicular line that's going through the midpoint of segment AB. Point P is the midpoint. So this is called a perpendicular bisector. Since we're using the word perpendicular, we know it makes a 90-degree angle, and it bisects, which means it cuts the segment AB into two equal parts. So now we know that AP is congruent to PB. A point is equidistant from 2 points if its distance from each point is the same. So equidistance just means the same distance, fancy math word. And then we're told that if a point on the perpendicular bisector of a segment, then it's equidistance from the endpoints of the segment. And that's what we see here in this picture. Here, point C lives on the perpendicular bisector of segment AB. Since point C lives on the perpendicular bisector of this segment, then the distance from A to C is congruent to the distance from C to B. That's a rule that's going to be true all the time. No matter where point C lives on this bisector, for instance, I could put another point here, point D, then this distance is going to be congruent to this distance. Okay, so no matter where that point lives on the perpendicular bisector, it's always congruent. The distance from the bisector to the endpoints of the segment is always going to be the same. All right, so in example 9, we're told that line MN is the perpendicular bisector of ST. So what segment lengths in the diagram are equal? All right, well, first off, let's start off with what the picture gives us. TQ and QS, those are obviously the same. So TQ is congruent to QS. What else? Let's see. This line right here means that TN is congruent to NS, so those two are the same. And then finally, point M lives on the perpendicular bisector of the segment TS. So based on the rule we just talked about, we know that the distance from M to T is the same as the distance from M to S. So those two segments are congruent. So MT is congruent to MS. And that's all we know about congruent pieces in this diagram. Now, in part B, we want to explain why point Q lies on the line MN. So what we're trying to prove or explain is that point Q has to live on the line MN. Well, MN, that line, is the perpendicular bisector of TS. This symbol right here just means perpendicular. It's an upside down capital T. It's perpendicular. So we're told that line MN is the perpendicular bisector of TS. That was given to us. Well, on the previous page, we had a rule that said that the distance, if a point lives on the perpendicular bisector, then the distance from the point to the segment is going to be the same as the distance from the point to the segment. So, in this particular picture, since QT is congruent to QS, that means Q is on the perpendicular bisector. Okay? Again, this rule that we just talked about, since these two distances are the same, Q has to be on the perpendicular bisector. That rule was just given to us on the previous slide. So sometimes you just have to make an argument and explain why something is true with these geometry problems. And that's what we did in part B. The distance from a point to a line is the length of the perpendicular segment to the point on the line. So for instance, when a point is the same distance from one line as it is from another line, then the point's equidistant from the two lines. So here, if a point's on the bisector of an angle, then it's equidistant from the two sides of the angle. So for instance, point D is on the bisector of angle A. You can see here in this picture I have angle BAD is congruent to angle DAB. Those two angles are the same, so what this ray AD is doing is it's cutting angle BAC into two equal parts. It's bisecting it. Since point D lives on the angle bisector, then the distance BD is the same as the distance DC. And that's just a rule. As long as a point lives on the angle bisector, then the distance from the angle bisector to the two rays is going to be the same. And that's it for this video. Again, these are bisector basics. It's things you probably already know, but I just wanted to go over them with you just in case you didn't remember.